So what are the benefits of intermittent fasting? This is an article that came out in 2020, and it just kind of gives a summary of all of them. Once you see this, you'll think, why don't I do this? So ketones, blood, what happens to your blood? Ketones go up, cortisol goes up, glucose goes down. That's a good thing for all of us with high glycemic index foods and diabetes and pre-diabetes. Triglycerides go down. Inflammatory markers go down. For all of us, that's a wonderful thing. Liver, ketones go up. You're more sensitive to insulin. Glycogen production goes down. In the intestine, ketones go up. In the skeletal muscle, insulin is more sensitive, so you can actually use the sugar that you have. It's good for structure and function. Brain function, oh my goodness, your hunger response is better. Cognitive function goes up. We'll end today's talk with that. Inflammation goes down. In your cardiovascular system, resting heart rate goes down, blood pressure goes down, insulin goes down, and in adipose and fat tissue, lipolysis, breaking down the fat goes up, and fat mass and inflammation goes down. So that's an overview. We don't have time to talk about most of these things today. We're going to talk about two things. Autophagy. Autophagy is automatically eating ourselves. It doesn't sound good, but it really is, because we don't eat the good parts. We eat the broken parts, and it helps us. So we're going to talk about autophagy and ketosis. Here's a study from 2008. Autophagy fights disease through cellular self-digestion. Okay, I know it sounds weird, but it's really a great thing. Autophagy. What is autophagy? When you stop eating, we'll show in the next slide why this happens, but you make these autophagosomes and you start breaking all these broken pieces of proteins, fats, carbohydrates, nucleic acids. Your body starts making these vacuoles. It surrounds these broken particles, it encapsulates them, and then it combines with the lysosome. The lysosome puts all of these enzymes into this, and it eats it up, and instead of having all the broken pieces, you have pure carbohydrates, fats, proteins, nucleic acids, and you can use all that was junk to start building your body again. Now, that happens periodically. It goes on all the time, but it periodically speeds up. We'll show you in the next slide why. Your lysosomes are always out there gobbling up little tiny pieces of things, broken pieces in your cells, and it digests them and you recycle them. But this does it in a bigger way. There's a chaperone also, and the chaperone then goes out and gets the broken pieces, brings them to the lysosome, and breaks them down so you can reuse them. All right, so here's why this happened. This is 2019. The effect of calorie restriction on autophagy. When we eat less and we're not eating enough, then our body starts going into eating itself. Why? Well, this is a complicated diagram, but I'm only going to talk about part of it. Here's insulin. If insulin is high, it notifies mTOR to stop this production of this complex to make these. Now, when you're starving, or you're just intermittent fasting, or you're fasting, or you're just eating less than you need, AMP, adenosine monophosphate, goes up. And so what is that? ATP is the energy for your body. ATP is what makes your body run. When it gets low and it's been used up and it turns into AMP, AMP kinase kicks in. And what does it do? One of the things it does is it works on this ULK1 to start this autophagy initiation. This ATG complex then starts making these very rapidly. They start engulfing all of these broken pieces. They connect with the lysosome and you have autophagy. It's an amazing thing. Probably one of the most beneficial things that you can do with your metabolism. Think about the last, 10,000 years. And there were never times when we just had food all the time. We would go through cycles where we had less and we'd have more. In those cycles of less, we would start breaking down the broken pieces and clean house. Imagine a grocery store. They bring all the food in and they put it on the shelves. And they bring more food in and put it on the shelf. And the boxes are just everywhere. Pretty soon you can't even get to the shelves because of the junk. We're that way too. We break down, we have trash we need to get out. And so this helps our body clean house. But probably the most important thing is ketosis. It is the most amazing thing to me. And these are my favorite slides. I will share them with you. This is a study from 2019, and it's looking at the neuroketotherapeutics, or the properties of ketones that really help our brain, is what this is going to talk about. Here's the diagram. It is my favorite by far. And so to give you the landscape here, this little square is a liver cell, a la the liver. And then over here is a big square cell, and it is a brain cell. And in both of these is a circle. This is the mitochondria. This is the powerhouse that's making ATP, the energy for us. Now, what this shows is when you're fasting, what happens then is fatty acids go up because you're not eating anything. You start breaking down your own body and fat goes up. At the same time, insulin goes down. Okay, well, what does that do? Well, what it affects is this enzyme right here in your liver that allows fat to go into your liver to be burned up as energy. And so this fatty acyl-CoA is actually encouraged to function when insulin is low and fatty acids are high. So whether you're fasting and you have this situation, or you're on a ketogenic diet, and same thing with ketogenic diet, not eating many carbs, insulin is down, fatty acids are up, makes this enzyme kick in. And so you start taking all this fat that your body is breaking down, it goes into your liver and it turns into acetyl-CoA. Acetyl-CoA is the main chemical and energy metabolism in your body. Fats, proteins, carbohydrates, no matter what it is, they all go through this. And so these fats are broken down by something called beta oxidation into acetyl-CoA. It goes, then there's so much of this being built so fast, it connects together. One acetyl-CoA with another one, it makes acetyl-CoA. This then, now the coenzyme A is gone. We need more coenzyme A. So this acetyl-CoA, is going through HMG-CoA reductase, and it makes acetoacetate. What is acetoacetate? That is a ketone. And so these ketones are just being created in mass. It can be acetoacetate, beta hydroxybutyrate, it goes back and forth between them, or acetone. Have you ever noticed when people fast or a baby gets sick, real quickly their breath gets this sweetness on it? That's acetone. It's like nail polish remover. That is a ketone. Now, the interesting thing is your liver can't use ketones for energy. What it does is it pumps them out into the blood, into the circulation here. They go up, both beta hydroxybutyrate, acetoacetate, the two main ketones. And where they go to your muscles for energy. Athletes have known this forever. They actually take a supplement. Up here in the top, you can just take beta hydroxybutyrate, goes right into the liver, gets shunted over here. Your muscles can use it, but also your brain can use it. And so what this shows is this massive amount of all of these ketones go to the brain, and the brain reverses the process with beta hydroxybutyrate, acetyl-CoA to acetyl-CoA. It goes into this TCA cycle and it produces FAD, NAD, and ATP. It creates energy for your brain. Sometimes these things work, but they don't work good enough to really do anything. So we're going to look at something here in this last slide. I didn't show you this, medium chain triglycerides. They're short fats. Where do you get them? Coconut oil. You get some in milk, or you can just buy MCT oil. Well, what that does is it bypasses this enzyme. So if insulin's high, you eat a bunch of sugar, doesn't matter. MCT oil goes in. It doesn't matter if you're fasting or on a ketogenic diet. You can eat these and it goes right into your liver. Now, why is that important? This last slide shows why. Medium chain triglycerides, or ketones, because that's what they make instantaneously, and Alzheimer's disease. And so we'll close with this. Here's a healthy young person. God bless you all, young people. And you can see here that your brain needs to be up here at about 88% to function. And so young people have lots of glucose here in the blue and then ketones in the light blue, doing well. Older adults, still fine, still up here, enough energy to have your brain functioning, no memory problems. Then all of a sudden you drop below that 88%. Not enough sugar, sugar isn't working like it should, and you start having memory problems. This shows me that you can actually do something about this. If you fast, this obviously works, but you don't even have to be fasting, just taking MCT oil. And what it shows here is that the percentage of what you're burning for energy increases with MCT oil. So you're getting more ketones, and all of a sudden the brain is up here able to function again. This is 30 grams per day. 30 grams is about 2 tablespoons. Can you get this to function? Yes, by taking MCT oil or by eating coconut oil. And then if you take 45 grams, that's like 3 tablespoons a day, it brings it well up here into the functioning where brain functions perfectly, even in older adults that have memory issues. So thanks to the students for putting this together. If you want more detail, we've got some other videos that talk more in depth about this. But all this shows is one of the most popular diets that's out there today is this fasting, time restricted fasting, or intermittent fasting. And does it work? Yes. We'll see you in the next video.